Hello, welcome to 9.3. This is going to be our video on series. Series is the sum of all the terms in a sequence. So we're still going to be looking at the patterns from what we were doing before with the arithmetic and the geometric sequences, but now we're going to be adding those terms together, and we have some new formulas that go along with it. So the first part, if you need to find the sum of a series with many terms, we can use the formulas for geometric sequence, which we have listed right here. We also have our arithmetic right down here. And then these are the unique formulas for geometric. Notice we're going to see some familiar pieces, like we have our first term, which is our a sub 1. We have our r, which is the rate. And then we have our n. But we're going to denote this with s of n rather than a of n, because now we're talking about series. So it's the sum. Okay, and then for the arithmetic, same idea. The arithmetic is going to be a little bit tougher, because what we have to do is we have to find our first term in the sequence, but then this a of n is also going to be a new idea here that we have to find as well. So we're going to be using the arithmetic sequence formula to find the series, and it'll make more sense once we get to that part. All right, so here's our first one. If we were to list these numbers in order, it would start 1, 5, 25, 125, and it would continue. And if we look at these here, it's the same exact idea. We're just adding them each time. So to find this, we want to find the first 10 terms. That's our n value. So s of 10 is going to be our a of 1. I'm just going to list some of this information off on the side here. Is this term right here, 1. So s of 10 is equal to 1. And then it's 1 minus our rate. We haven't figured out the rate yet, but to go from 1 to 5, assuming this is geometric, we're going to multiply, so we would multiply by 5. And that is consistent. We keep multiplying by 5. So that means our r is 5. To the n power, we already talked about how we're trying to find the first 10 terms, so n is 10. Divided by 1 minus our rate again of 5. The hardest part about doing this part is not setting up the formula. It's actually making sure you do it correctly in your calculator. So this is what I'm going to suggest. Let me go ahead and let me get the Calculator Pro here. I suggest typing it similarly to how I wrote it here. So I'm going to do 1 with a parenthesis, and then I'm going to hit my fraction button. So now I'm going to do 1 minus 5 to the 10th power, and then arrow down, go 1 minus 5, and then put the other parentheses. It looks very similar to how I wrote it out, and then this should give me the right answer. We are expecting a pretty big number here, and we do get just that. It ends up being 2,441,406. That's what we would get if we added all of the first 10 terms together. So our s of 10 is that number. All right, let's try that again here. A little different pattern this time. So note right away, our a of 1 is 2. That's the first term in the sequence, which is the first number we see. Our rate, which is to go from 2 to 8 through multiplication, would be times 4. And then same thing, 8 to 32 times 4. It's consistent. And then lastly, our n is first 10 terms, so we're trying to find 10. So s of 10 is going to be equal to our first term, a of 1 is 2, 1 minus 4 to the 10th power over 1 minus 4. Writing it out is pretty simple. It's just making sure to type it in your calculator correctly. So 2 parenthesis, fraction button, 1 minus 4 to the 10th, 1 minus 4, close off your parenthesis, and then we get this number. So it ends up being 69,905 for the s of 10. All right, now it's given us an application problem. It says a virus spreads through a country and the number of new cases doubles each hour. The phrase doubles, make sure you're thinking about what factor that is, or rate. In this case, it would be times 2. And then each hour, if there are 100 cases to start, how many total cases of the virus will there be after 24 hours? They also told us the very first number of cases is 100, so that's going to be our a sub 1. And we want to find after 24 hours, so that's going to be n equals 24. So now when I write this out, I know everything that I need. I have my r, I have my n, and I have my first term. So we are going to find s of 24. It's 100 cases to start. It's 1 minus our rate of 2 to 24 hours over 1 minus 2. 100 Okay, type that all in, and we get a really big number here. So this is the total number of cases that we would get. It looks like it's 167,772,000. Oop, hold on 1 second here.
Sorry.
It's okay.
I've never had it blocked on me before.
Okay, so this is actually 1,677,721,500. Okay, and that would be cases. All right, here's our next one we're going to look at. This is an arithmetic series, so it's going to be a little bit different. And like I said, it's actually going to be a little bit more work too, because we have to find the a sub n, which is like finding the regular series or the regular sequence. So we want to consider the arithmetic series of 20 plus 18 plus 16 plus 14. So we do want to note that our a sub 1, the first term, is 20. We also want to note that our n value here is 25 because we're trying to find the first 25 terms. And then this part here, this is where we have to relate it back to our old formula. We need to find the formula so that we can find the 25th term in the sequence. So this is that d times n plus a sub 0. The a sub 0 part, we can just go backwards because it looks like we're going down by 2. Oh, I got to list that as well. Our common difference is -2 because it's going down by 2 each time. So then we can assume that for this pattern, it would be a of 25, -2 times 25, and the a sub 0 part is if we were to go backwards, we would do the opposite of subtracting 2. Like the term prior to 20 would have to be 22. So we could put plus 22. This would give us -50 plus 22, which is equal to -28. So that is our 25th term in the sequence, and that's actually what's going to have to go here. That's what we're plugging in to the formula. So now we have everything that we need. So s sub 25 is going to be, n value is 25, our a of 1 is 20, our last term is -28, all divided by 2. So when you type this in, 25 parenthesis 20 plus, or you can just do minus 28 since we're subtracting ultimately. Oh, and I forgot my fraction button, so I'm going to hit that really quick. 20 minus 28, and then divide that by 2. We end up with -100. The reason we ended with a negative number here, which feels weird when you're adding, but we started with all of these positive numbers. Eventually we would get to a grouping of negative numbers, and there just happened to be more negatives than positives. Okay, let's try that with this one. Consider the arithmetic series for 30 plus 25 plus 20. Looks like we're going down again. And if we look at it, we're going down by 5. So it's -5. That's going to be our common difference. So the difference is -5. The n value that we're trying to find is 14. The first term is this 30. And the a sub 0, which we need for the sequence formula, the a sub 0 is 35. So we're going backwards here. Okay, so then we just got to find our a sub n, which in this case we want to find the 14th term in our sequence. So the common difference would be negative 5 times our n value of 14, and then it would be plus 35. And one more time, this is just our sequence formula that we were using before. Difference times n plus a sub 0. So I just filled those in right here. All right, now if we type this in, we would have negative 70 plus 35. That is negative 35. That is going to be our a of 14. That's what's going to go into our a of n value. So now using this formula up here, this one right here, excuse me, we are going to write this out. So s sub 14 is 14, and then it's going to be our first term of 30, then it's going to be minus 35, because that's our last term, or plus negative 35, all over 2. Just going to double check. Yep, I got everything I need there. So now I can type this in. 14 parenthesis 30 minus 35 divided by 2, and we get negative 35. So just a little bit more work for this formula, not too bad. Last problem here. So it says a construction company is laying a natural gas pipeline. Several sections of pipe have been laid in a pile at the construction site. There are 12 sections of pipe in the bottom row of the pile. Each row has one less pipe than the row below it, decreasing arithmetically, and there are 8 rows of pipe. So we want to write a rule for the number of pipe sections in the nth row. This is actually going to be a sequence because we're looking for just one specific number in the pattern. So our sequence here, and since it's decreasing arithmetically, we're going to use that formula a sub n equals d times n plus a sub 0. Okay, so in this case, it is going to be our common difference we know is it's going down by one less pipe. So that's just going to be negative 1. That's this part right here. So that means our common difference is negative 1. The n value can be anything, so we're just going to leave it as n. And then it said it started with 12 sections of pipe. So if we want to go, sorry, that's the bottom row. There's 12 sections. So that would be the first row, right? The very bottom row is 12. So that would be our a of 1. If we want to go backwards 1, we do still need to think about that. So then we would have to do 13. So it would be plus 13. So this is going to be our formula for the nth row. Then if we want to find the number of pipes in the 8th row, we can go ahead and find a sub 8, which would be negative 1 times 8 plus 13, which is negative 8 plus 13, which is 5. So in the 8th row, we only have 5 pipes. Then we get to our last part here where it says find the total number of pipes in the pile. So in this case, since there's 8 rows in total, we want to find the series S of 8. So then we would use the arithmetic series that we were just practicing up above, which would be this. I'll just write out the formula really quick so we remember that. And a sub 1 plus a of n over 2. We're finding 8 sections, so it's 8. Our first term in the sequence was 12, plus the last one, because they decrease each level, it gets to 5 divided by 2. So 8, 12 plus 5 divided by 2, and we get 68. So in total, there are 68 pipes sections in the pile. And that is it for this one.